So hi guys, welcome to the BinaryEdge Videocast episode 2. Today we're doing things a little bit different. We're actually, most of the team is in Portugal. So we're actually currently, most of us in the same room. João is in a different country. So this is a little bit weird for us in terms of recording. It might be a bit of a shorter episode as well. That was Rosie coughing. So I'll actually pass over to Florentino now, who's about to start his presentation.
So, hi guys. Um, I'm a bit of a lazy person, so I usually like to find simple ways of doing kind of complex things. So, today I'm going to talk about how to filter similar images for lazy people like me. So, a concept that most people are familiar with is the concept of hashing. But most of the times people think about cryptographic hashes. So this kind of hashes is kind of random, and data is used like a random seed. So the only things that you get from this kind of hashes is that the same data probably will generate the same hashes, assuming non-collisions, and different data will have different hashes. But there are other kinds of hashes, and one kind is the perceptual hashes. And this is what we can use for images. Basically, we can generate an hash, and we can compare images regardless of their size, slight differences in color, and I don't know, rotations, some transformations of the image, and you can still find similar images. So, how can you do this? One very simple algorithm to do this is basically you pick an image, you reduce its size, you pass the colors to grayscale, you compute difference between adjacent pixels, and you assign bits by checking if two adjacent pixels have an increase or a decrease in color, in this case in the intensity of the grayscale. And finally you transform this bit sequence into an integer, and thanks to this you get an hash, a very simple hash that you can compare against the hashes of other images, and you can more or less reliably get the similarity between images. So what I'm going to show you is how you can experiment with this in Python.
Good. Okay. You can show us.
So here I'm opening the image. As you can see, the image, I don't know if you can see very well because this is small, is a login screen for a Windows machine. You can compute the hash and it returns a string. The hash depends, you can configure this for the size of the hash. Bigger hashes will take longer to compute, will take longer to compare with the others, but might be more accurate when you do the comparison. So as you can see, the package that we are using is image hash. We have different algorithms here. Average hash, dhash, and phash are the most discussed online, I think. The one we are using is dhash, the one I explained. But I'm going to provide links so you can check out the other two, which are very simple also, and have more or less the same steps. So I want to find similar images to this one. So I have here a folder with lots of images, and I'm going to compute the hashes for everyone, and I'm going to store the file name and the resultant hash. So then I'm going to use a distance function, compute the differences between the initial image and the other hashes that I've got. So this is one other step that you can use different algorithms to calculate the difference. Here we are talking about string differences, so you can use, for instance, Hamming distance, which is what we are going to do. You can also use Levenshtein distance. You can use lots of things. So here I'm going to run through the hashes that we've computed, and we have here a list of um, supposedly similar images, and the distance between the hashes of the first image and this one.
So the lower the number, the closer it will be to the original image.
Exactly.
Okay.
Here I've established a threshold of 10. This is also configurable. I mean, if you have a bigger hash, it would be sensible to have a bigger threshold as well.
Okay.
So I picked one to see what kind of results we got, and as you can see, we also have a login screen of Windows, which is very similar to the first one, but still different. And as you can see, this is very small code, very easy algorithm, and it just works. It's not perfect, but for lazy people like me, it's really good. And that's all I wanted to talk about for today.
That's actually pretty cool. So to give you guys a bit of context of why Florentino uses this stuff, one of the features that we have on the BinaryEdge platform, as I mentioned on episode 1 as well, we screenshot everything that we can find that is screenshottable. What we mean by this is things like HTTP services, VNC, RDP, X11, all of those. And one of the properties of our platform is that you'll be able to come up, choose a screenshot, and say find similar screenshots to this one. That's because it automates the process of trying to find critical things like SCADA, or excluding common things like Windows logins. They're usually not very interesting to our clients, so our clients just use these types of algorithms to exclude them from what they're currently viewing on the platform. So next up, Florentino, I would ask you that you actually switch. Will be Ines. Ines is our designer at BinaryEdge. Let's proceed. Ines.
Hey guys, so for the last couple of months I've been learning a lot about logo design and colors, and not only does it take a lot of work and research to create a good image, it also takes a lot of thought into choosing the right colors to use. Color is extremely important in marketing and branding. It gives visual appeal to a product, and it's also a great way to help people connect to your design on an emotional level. I'm going to share my screen with you guys now.
Need some help?
I think it's okay.
Yep, all good.
So I'm going to be very quick. If you go to Google and you write color emotion, go to the images, and you're going to find amazing infographics and emotion color wheels that will help you understand this subject in a better way. This one, oops. Okay, so this is one of my favorites, where you have 7 different colors with their emotional meaning and a good amount of really well-known logos connected to each color. So I think you can have fun learning more about colors and your favorite brand and the message they want you to receive when you look at their image.
So let's say you're starting to design a logo. Do you start by the colors? Do you start by the format? What's usually the process for this?
I usually write a lot of keywords that I think are connected to the image that I want, and I start by sketching the image, and then I work using Illustrator, and the color is the last thing I choose.
Okay. So it is the last thing. All right.
Yes.
Okay. Thank you very much.
Thank you.
So we'll now pass over to Marco. Marco, can you give us a quick shout on what you're going to talk about today? I know
Books.
you're going to talk about books. Nice. Interesting books, I hope.
Yeah, always interesting.
Okay. So I'll now pass over to Marco. At BinaryEdge, Marco handles things with technology. He helps Tiago Martins, who's our CTO, handling everything from infrastructure, code quality, and if we need some new piece of software running on our data pipeline, Marco and Florentino work on that together. He's definitely our hacky, gets it all working guy.
Jack of all trades, firefighter.
He's our firefighter, that's for sure. And I'll now pass over to Marco.
Okay, thank you. So today I want to talk about books. Thought about I could show maybe a new tech or piece of code, but one of the best ways we have to share knowledge is really books, and they are kind of underrated nowadays, but it's still the best way we have, and I think it's really important in the technology field. People read from blog posts to forums to stuff like even Slack Overflow, just go over some questions, and books are one of those key points of knowledge. So one of the books I started reading recently, it's called Site Reliability Engineering, How Google Runs Production Systems.
Can you actually Google it and share the screen with us? That way we'll be able to at least see the cover of the book.
So let me just,
in case some people want to buy the book or something like that.
So just give me 1 minute.
Sure. If you want to keep talking about the description of the book, that'd be lovely.
Yeah. So this book was written by a group of engineers from Google. Explains what they do. It's not really a normal book in the sense of other technical ones from O'Reilly, where you have a story from chapter 1, chapter 2, you build a system piece by piece. This is more of a mix of essays and best practices. So each chapter is written about a different subject and by a different set of Google engineers. So they go through things like the principles, what do you need to focus on, behaviors, what's basically the work of a reliability engineer, best practices, so they give examples on what they do on their day-to-day basis, what's important for them when building these large systems, but also on a management perspective, because the work of an engineer, it's not just the technical side, it's people, most of it. So they give you examples about training, about how to deal with people, how to deal with meetings, expectations. So it's quite a good book to read regarding that. So let me just share my screen,
sure,
so you guys can see. Yeah, sure. So this is the book, Peter. Sorry, the connection's a bit slow.
Fine.
I thought I already had opened it. Well, then I'll share the links on the
we'll
aftermath.
provide the links on the.
Yeah,
try to open it, but sure. And what would be the second book you want to talk about?
So the second book, now this one is more technical, with example from the beginning to the end. It's called Building Microservices by Sam Newman. Microservices are the new buzzword since, well, every year it's the new buzzword. But nowadays it's been mostly focused on Docker. So whenever you talk about microservices, everyone talks about Docker. But Docker is just a tool to help you achieve microservices or with microservices. This book doesn't talk about Docker, but it does mention containers in the meanwhile. But it focuses more on the concepts behind building a microservice. So how do you align the needs of the service you're building with the organization? How do you split your monolithical application, the monster you have in your organization, into different services? How do you integrate them? How do you think about deployment and testing? So it's a very good book for beginners, from developers to architects to ops, but even for more senior people. Well, most of the knowledge you get from this book you already know, but it's good to refresh it and understand different ways of looking at the problem. So I would recommend this one also. And since we're talking about microservices, the third book is, well, it's independent. Doesn't they don't sell it in any publisher like O'Reilly. It's called The Docker Book by James Turnbull. It's great for beginners. Many examples. It's updated quite often. So, for example, I bought the book almost 2 years ago, I believe, and it's been having updates every 2 months. So even so, we already have Docker 1.11 now. The book has been updating and following all of those new concepts that Docker is releasing. So it talks about Swarm, about Compose, and it does provide many examples from testing it, from integrating, from using console with it, and it's written really easily for beginners. So that would be my third book to recommend for today. And I'll share then the links and a bit of the description afterwards. So if you guys want the links to the books, you'll have it. And that's it from my side. And if you have any questions regarding the books or more books, just shout out.
All right.
That's all from my side.
So as we mentioned, this episode is going to be a bit short compared to the first one, and also a little bit faster. Tiago Martins was actually supposed to talk today, but he's just sitting over there with a cold and he can't really talk. But I promise you'll have him next week. Thank you very much for watching, and make sure you send us some comments and some ideas of things you'd like to hear us talk about. Thank you.